We're going to take a look at the graphs of exponential functions, and we need to know what an exponential function is. And it is a function that can be expressed in the form of f of x equals b raised to the x power, and that's kind of the key. If you're raising any number to a variable, you're getting some form of an exponential function. B is greater than 0, and it can't be 1. Now, b can't be 1 because any 1 raised to any number is just going to be 1, so nothing's going to be changing there. Now, exponential functions, along with logarithmic functions, have all kinds of applications. And we're talking about things as simple as compound interest and population growth. We're talking about things like carbon dating, where these atoms have half-lives, and so they decay over time, and they decay in an exponential type fashion. So that's just a couple examples, but they are all over the place. But we're just going to start and look at what the graphs are actually doing, and so that we can kind of get an idea of what we're kind of talking about. We're going to look at this situation, where we start adding things and subtracting things, and we're going to add things to the exponents and move things around. Now, you can do all kinds of stuff to the exponent. You could raise the exponent to an exponent, but that doesn't change too much. The only thing would be if you add or subtract something to it. We're also going to take a look at what happens to the function when we multiply it all by -1. The first thing we're going to look at is what's happening to our graph when the base changes. Now, remember, the basic basic function that we're talking about here is b raised to the x power, and that makes it an exponential function. And so we're going to start off looking what happens when the base changes. So the red function here, 2 raised to the x power, is the red curve. 5 to the x power is the blue curve. And then the purple curve is 10 to the x power. All of these are exponential functions. And this is the trademark design of an exponential function. It climbs very, very, very quickly. Okay, and so think about what's going on here. Remember, a function, f of x, is referring to the y values. And we're wondering what's happening to these y values when our x changes. Our input is going to be different. So when you're raising something to an exponent, the numbers increase very rapidly. Here when x is 1, when we plug it in here, 2 to the first power is 2. Okay, but if we change our base to a 5 and still plug in the same value of 1, we're all the way up at 5. Okay, and then when we're on the purple one, when we're raising 10 to the first power, we're way up here already. Okay, so this steepness, this rapidly increasing y values, again, is the trademark of what an exponential function is really doing. By the time we even get out to 5, we're all the way off our graph. Because just think about it, 2 to the 5th power is 32. So, it's way up here. 10 to the 5th power is, 1 with 5 zeros. So it's way, way, way up there. So, once the base is bigger than 1, the steepness really increases. Okay, and it's almost pointless to go much more over 10 because, with being this zoomed in, they would almost be vertical right away. Now let's think of some other things that's going on here with our function. Again, we're going along this x-axis and plugging in different x values and seeing what happens to our y value. If I zoomed way out, these lines would look vertical, but we're still allowed to plug in some really big numbers and we would get a result. It would just be some crazy, crazy big number. And we're still allowed to plug in any negative number also. So the domain of any exponential function is all real numbers. Another thing that you really want to notice as a similarity is all of these are going through 0, 1. And again, think about what that means when you're talking about a function. 0 is our x value. That's what we're plugging in here. Okay, and then it doesn't really matter. In fact, it doesn't matter at all what the base is, because any number raised to the 0 power is going to be 1. And so that's why they all share this point here. And now it's hard to see, but all of these kind of converge right here. Okay, and then they kind of keep going. And even if we zoomed out, we would see nothing down here in our third quadrant. But think about what's going on here. We're plugging in negative x values, and so our exponent would be negative. And so what does that mean? A negative exponent, things flip around. Okay, so for instance, if we plugged in f to the negative third, right, that would be 2 to the negative third, which is really 1 over 8. So already when we're here at 3, even on the smallest base, the y value is 1/8. So once we get out here to negative 10, we're talking about a really, really tiny positive number. And so the x-axis serves as an asymptote. And so this is something that all exponential functions do. It just, the base determines how quickly it gets down into these really, really tiny numbers, just like the base determines how steeply it'll climb. Now we're still looking at just changing the base, and we are still using positive values as our base, but you notice how the graph is just completely switched. Okay, so when our base is between 0 and 1, right, these are all fractions below 1, the graph is still an exponential function, right, but it's on going in the opposite direction. But again, look how, we're just looking at how things change, and let's think about what's going on. Why would this happen? Well, okay, so still, no matter what, we're plugging in x as 0 here, no matter what you raise to the 0 power, the y value will become 1. Okay, so they still share this point. And when we go out to the positive values, look how small these things get. Okay? But again, think about what we're talking about. When we plug in the value, let's just do 1. 1/2 raised to the first power, the y value would be 1/2. 1/10 raised to the first power, the y value would be 1/10. Okay, but then as soon as you get a little bit bigger, then you're getting extremely, extremely small numbers. Right? 1/10 raised to the fifth power is, 1 over 1, 1 over, a 1 with 5 zeros. So it's very, very tiny already. Now this one is really getting close to 1, and you can see how flat it really is here. Okay, because we're almost plugging in 1 raised to some power. So that if it was just 1, it would be going along here and it wouldn't change. So it's not exactly 1, but very, very flat. Now if we get to the other side, again, a negative number flips the fraction. Okay, so if we're just looking at this first one, 1/2 raised to the x power, right? When we put in negative, let's say 2, 1/2 raised to the negative second power would be 2 to the positive second power, which would be 4. Okay, so already right here, we're already up here at 4, and then climbing steeply in the other direction because these things are flipping. So for here on out, I'm going to just be referring to, the base being 2. And everything that we are going to do for the next couple slides here would be the same no matter what your base is. And, when the base is 2, you get a nice, obvious curve. It's not quite as steep, so you can kind of tell a little bit more what's going on. But the difference, and this is how it's going to be too. We're gonna have the basic 2 raised to the x power on here, and then we're going to manipulate it and see what we can do. If we multiplied this by -1, it flips over the x-axis. It reflects over the x-axis. And, think about what's going on with a function again, right? We're going along and plugging in values. Okay, so at 1, right? If we used the green colored curve, right, it'd be 2 to the first power, which is 2, right? But if we did the same thing with the blue colored curve, plug in 1 here, 2 raised to the first power is 2 times negative 1 is negative 2. Okay, and we could keep going on that way. 2 squared is 4. 2 squared is 4 times negative 1 is negative 4. Okay, so, and this is something that happens with just about every function that I can think of. If you take the basic form of any function and then multiply it by a negative, you are reflecting it over the x-axis. So now we're going to look at what happens when we add a value to our basic exponential function. Alright, so this purple one here is still 2 to the x. It's still the exact same shape that we've been looking at. Alright, and now the black one, we're just going to still do 2 raised to the x power, but then we're going to add 3 to it. And then so notice what happens. It goes up 1, 2, 3. It's all the same, but it just moves up 3. And you may be saying, well, look, it's getting closer, so it's not really the same. But remember what's happening. It's climbing steeper and steeper. Okay, and so just because we can see more of the purple and the red one doesn't mean that they're different than the black one. They're all the exact same shape, just shifted up. Okay, and so then the red one, this would be the rule for the red one, and it drops down 2 spots. And again, think what's going on here. If we're plugging in values for x, is what, and again, that's what a function is. When we get to 1, we'll do a simple one. 2 raised to the first power is 2. Okay, so let's go do the same thing to this function, the black one here. 2 raised to the first power is 2, and then we add 5. So 1, 2, 3, 4, 5. The red one, we raise to the first power. 2 to the first power is 2. Minus 2 is 0. Okay, and so this number here shifts the curve up if it's a positive number and down if it's a negative number, and it shifts it exactly that far. Now we're going to look at what happens when we add or subtract numbers to the exponent. Okay, here's our one that we keep looking at, 2 raised to the x power. And now our green and blue one has shifted left and right. Okay, so the blue one would be adding 4 to our exponent. And then it shifts to the left. So why does that happen? Okay, so let's take a look at our basic one, that we consistently look at here. Let's just do 2 to the first power. Again, 2 to the first power is 2, and that's why we have the purple curve going right here. Now, 2 to the first plus 4, 2 to the fifth power, is 32. So we're already way, way up here. Okay, and so for that form to happen, right, it kind of shifts over. And you notice that it shifts over exactly that far. 1, 2, 3, 4. All right, likewise, let's look at this. If we plug in that same value of x, 2 to the 1 minus 2, so that would be 2 to the negative first power, would be 1/2. All right, and then if you look at this value, it shifts to the right 1, 2. Okay, so the value that you add or subtract to the exponent part moves the graph, it just shifts it, translates it that many units, but kind of in the opposite direction here. So when we added 4, it translated it to the left 4 spots. When we subtracted 2, it translated it to the right 2 spots. So we can move these curves all over the place. We can do more than just one thing to it. So, our orange curve is still 2 to the x power. Okay, and so that's what we're going to be comparing it to. And now the curve is the same because we're using the same base. It's just shifted around a little bit. So remember, this number is going to move it up or down, depending if it's positive or negative. In this case, it's negative, so it's going to shift it down 5. This number, when you add or subtract to the exponent, will move it left or right in the opposite direction of what you're doing. So in this case, it should move to the left 3. So let's look at this value here. This is an easy one to find. We're saying it should move down 5, 1, 2, 3, 4, 5, and to the left 3, 1, 2, 3. Okay, and so we can do that with any point that we want. And we can move these graphs all over the place. And we're going to look at another example as well. So this one's a little bit harder to kind of comprehend because of the reflection here. But, we still are looking at our basic 2 to the x power. And, this value is still going to shift it up. And it's going to shift it up 2 in this case. So if we look over here, it's easy to see it goes up 2. This value is still going to shift it to the right, because again, you're going opposite of this. And, it's a little hard to see, but we can look at this point, and it does shift it right 3. Okay? This value reflects it over the x-axis, and that's why it's shaped upside down. Okay? It's still the same curve, just moved around and reflected. Okay? The only way you can change the curve is by changing the base. So now, I said something a little earlier about how these things hold true with just about every function, at least that I can think of. And so anytime you multiply your overall function by a negative, it is going to reflect over the x-axis. Anytime you add or subtract a number to the outside, if there's parentheses involved in some functions, that's going to shift it up or down in the same direction as the sign. Anytime you're manipulating the x value, and oftentimes this happens inside of parentheses, you're going to move it left or right in the opposite direction. So, this is something that is a reoccurring theme with functions.